All right, so welcome back to section A6, part 1. In this segment, we're just going to be continuing along with those examples. And we left off, I think our last one was number 4. So let's go ahead and jump back into number 5. So number 5, we're given 7 times p minus 2. Actually, let me backtrack. We're going to do a different one. We're going to do 4 times 3 plus 2x equals 7 times x minus 5. So this problem has an extra step that we haven't seen before. Anytime you have parentheses, first thing you want to do is clear those by distributing. So just like we saw in section AR 1.4 where we distributed, we're going to go ahead and distribute on both sides. So on the left side, we have 4 times 3, which is 12. 4 times 2x is 8x, and it's positive, so plus 8x. On the right side, we have 7 times x, 7x, and 7 times negative 5, which is negative 35. Again, be really careful with those negatives. Make sure you don't lose any as you go through and distribute. Now the parentheses are cleared, we don't have any like terms to combine. On the left side, we have a constant and a variable term. On the right side, we have a variable term and a constant. So nothing to combine on those two individual sides. So we want to start moving things around, getting the variables on one side, constants on the other. So again, doesn't matter which order you do things in or which direction you move them. I will, in general, move variables to the left and move constants to the right. So I'm going to start by moving the variable terms. We want to move the 7x to the left. Since we're moving that entire term, we're going to subtract 7x from both sides. You're only dividing when you're just getting rid of the coefficient. So let's subtract that. Then on the left side, we have bring down the 12. 8 minus 7 is 1, so we're going to have plus 1x, which is just x, equals, the right side, we're going to cancel out those 7x's, and we're left with the negative 35. All the variables are on the left side now, so let's move our constant to the right. It's a positive 12, so we're going to subtract 12 to get that 0 that we want. Those 12s cancel out. We're left with positive x, which is just x, equals negative 35 minus 12. Same sign, we add and keep the sign. So we get negative 47. And our x no longer has a coefficient, so we don't have to do that other step that we've been doing where we divide at the end. If you just have an x, then you're good to go. Okay, let's go ahead and try another one. So next one, let's go ahead and do 7m minus parentheses 2m minus 9 equals 39. For this one, we have parentheses. So first thing we want to do is get rid of those parentheses. And one thing you'll notice is that there isn't a distinct number in front of the parentheses, but there is a minus sign. So that means we are subtracting that entire group of terms. And what we can do, if you want, you don't have to, is put a 1 in front of those parentheses. Just like with variables, if you don't see a number in the front, there's always a 1 there. Now we can think of this as distributing in a negative 1. We're just distributing in the negative. It'll flip all the signs. Be careful though, because you don't want to do anything with this 7m quite yet. We're distributing, clearing the parentheses, and then we'll deal with that one. So let's go ahead and distribute. -1 times 2m is -2m. -1 times -9 is +9, so +9 equals 39. Now, if we look at our left side, we have a couple of like terms that we can combine. So let's go ahead and combine those before we start moving things around. 7m minus 2m, we subtract those coefficients and keep the m. So we get 5m, bring down the +9 equals 39. Now on each side, our like terms are combined, so we can start moving things around in the equation. We only have one variable term on the left-hand side. So now we can get all of our constants on the right. So I'm going to take this 9, move it to the right by subtracting it, the opposite of addition. So we get 5m equals 30. And now our final step is to get rid of this 5. Since we have 5 times m, we do the opposite and divide. So we get, we divide both sides by 5. The 5's cancel out, and we get m equals 6. If you wanted to check this one, just make sure that you take the 6, plug it back into the very first equation that you started with. Just in case you messed up on simplifying, that'll help you kind of determine where your mistake was if you made one. Okay, let's go ahead and do one more problem, and this is the one where it gets kind of weird with fractions. So number 7, we're given 1/4 x, and I'm going to kind of spread this out a little bit just because we're going to be doing some multiplying in here. So 1/4 x minus 4 equals 3/2 x plus 3/4 x. Okay, so this one we have a bunch of fractions, and what we could do is go through and work with the fractions. We don't have to technically get rid of them, but I don't want to do a bunch of arithmetic with fractions. So what I'm going to do, and you can do this in the very first step, or you can combine like terms first. It doesn't really matter, but I'm going to do it the very first thing, just so that I don't have to do any work with fractions. What we're going to do is multiply by the LCD. And so we need to find the LCD. And so if we look at all of our fractions, and think of this just like when you're adding two fractions together, the common denominator, same concept, so same common denominator. We have a 4, a 2, and a 4. So the LCD, the smallest number that 2 and 4 both go into, is 4. Now what we're going to do is multiply every single term by 4. So I'm going to go ahead and write this in. I'm going to multiply this first term by 4, and I'll write it as 4/1 because we're multiplying by a fraction. I'm going to multiply this 4 by 4. I'm going to multiply 3/2 x by 4/1 and multiply 3/4 x by 4/1. So if it was a fraction, I just wrote it as 4/1 instead, just so it's a little bit easier to see. Now, when you do this, it should get rid of all of your fractions, and it doesn't change our solution because all we're doing is changing how large these numbers are. And so it's changing every single number. So as long as you multiply all of them, your solution's still going to be the same. So looking at the left side here with the 1/4 x, these 4s cancel out. So we're left with just 1x, which is x, minus 4 times 4 is 16, equals, now on our first term on the right, I'm going to just multiply straight across and then divide, just because they're nice small numbers. So we have 4 times 3, which is 12, over 1 times 2, which is 2. 12 over 2, or 12 divided by 2, is 6x, plus, on the right side, we can also, or sorry, the very term on the very right, we can also multiply and then divide, but one nice thing that I notice here is that those 4s cancel out. So we're left with 3 over 1, which is just a 3x. Now we have this nice equation, which doesn't have any fractions, so we can go ahead and start combining like terms and moving things around. So if we go ahead and look at the right side, we have 2 like terms that we can go ahead and combine. So I'll bring down the left side, and then 6x plus 3x is 9x. We have our variables now on the right, but we also have another variable term on the left, so we'll need to get those together on one side. We only have one constant. That constant's on the left-hand side by itself. There's no other constant terms. So I'm going to actually move the variables to the right this time, just because the constants are already all combined into one. So we have a positive x, so we want to go ahead and subtract x from both sides. Be really careful when you do this. The x's on the left cancel, so we're left with negative 16. And on the right side, these x's don't cancel. Think of this as 9x minus 1x. That gives us 8x. So again, put in that 1 if that kind of throws you off. It's just a good reminder that you're subtracting 1. And then our last step here, we have an 8 times x. So to get rid of that 8, I'm going to divide both sides by 8. The 8's cancel on the right. We're left with x. And then negative 16 divided by 8 is negative 2. So you can leave it just like this. You can also switch it around if you want. So write it as x equals negative 2, doesn't matter. But one important thing that I want to point out is that when you're on MyMathLab, so let me write this, let me do a different color. This is an important point. So on MyMathLab, they are going to have you write your answer as a solution set, which means that you're going to write your answer in these curly brackets, and you're not going to include the x equals. So it's going to give you these curly brackets, and you're just going to put your solution in there just as a number. So super important, make sure you take note of this. I always get a bunch of emails asking why their answer isn't correct. A lot of the time it's just because of how you're putting in your answer. So curly brackets, just put the number, don't put x equals. So again, come with questions on Tuesday. We're going to stop here, and we'll go ahead and go through any questions that you guys have then.